Guys, I hope you are all doing well. Let's see today's question. So today's question is from the topic of limits, and in this question we have been asked to find the value of this limit that is given by limit x tends to pi by 2, and in this case the fraction is given by numerator is 4 root 2 sin 3x plus sin x, and the denominator is further given to us as 2 sin 2x into sin 3x by 2 plus cos of 5x by 2 minus root 2 plus root 2 cos 2x and plus cos 3x by 2. Right? So this is the entire thing that we need to solve, and we need to find the value for this limit. So first thing I can use here, I can see is for the term in the numerator, I can directly use the formula of factorization that says sin c plus sin d, that is given by 2 sin c plus d by 2 into cos c minus d by 2. Right? So I can use the idea there in the numerator to get this. After that, I can also see here there is product of two sine terms present. So I can use the idea of defactorization that says sin c into sin d. I can write it as half of cos of c minus d minus cos of c plus d. Right? So that is the idea I can use here. So let's solve these two ideas first, and we can simplify then our numerators and denominators. So if I use that two ideas, the next step, now my step becomes limit x tends to pi by 2. I get here 4 root 2. So sin c plus sin d, if I use it here, I get 2 sin c plus d by 2. So 3x plus x, 4x, right? And 4x by 2, that is 2x. And we have cos of c minus d by 2. So cos of 3x minus x. So cos 2x by 2. So that is 2x. So we have this entire thing here. Further, I can solve this also. I get here 2. And if I see sin c into sin d, I can write it as half of cos of c minus d, right? So half of cos of c minus d, that is 2x minus 3x by 2. That is 4x minus 3x by 2. If I explain it to you, 2x minus 3x by 2. So 4x minus 3x by 2. So x by 2. So you get here cos of x by 2 minus cos of c plus d. So now I have to add both the angles here, x plus 3x by 2. So it becomes 4x plus 3x by 2. So it becomes 7x by 2. Right? So this is the working we are doing here. So here I get cos of 7x by 2. Right? This was multiplied. So 2.5 gets cancelled. After that, we have our remaining terms as cos of 5x by 2 minus root 2 minus root 2 cos 2x and minus cos of 2x by 2. Okay. So this is our entire terms now. Now let's try to simplify the numerator further. So I can write that as limit x tends to pi by 2. I had 4 root 2 into 2, that becomes 8 root 2, right? And I can also use the idea sine of 2 theta. If I write that as well, sine of 2 theta, I can use the formula for double angles that tells us 2 sine theta cos theta, right? So I can split sine 2x as 2 sin x cos x. So I get that 2 sin x cos x into cos x. So that becomes my numerator. Now let's try to evaluate the denominator. So in the denominator, I have cos x by 2 minus cos 7x by 2 plus cos 5x by 2 minus cos 3x by 2. So if I write first of all of these cos terms together, I have cos x by 2 minus cos 7x by 2 plus cos 5x by 2 minus cos 3x by 2 minus these two terms which are left out. I can write this as minus root 2 minus root 2. Again, I can use the formula for double angles here also. So I can write this cos 2x as 2 cos square x minus 1. Right? So if I write it like this in the next step, what I get? Minus root 2, 2 cos square x minus 1. Right? Well, let's try to simplify it further. Limit x tends to pi by 2. The numerator now becomes 16 root 2 sin x and cos square x. Further, now I have four terms of cos with me. If I start grouping together, I can group it like this, that cos of x by 2 minus cos of 3x by 2 together, right? And I can also group it as cos of 5x by 2 with cos of 7x by 2. So these two terms together and the other two terms together. So if I take it together, cos x by 2 minus cos of 3x by 2 plus cos of 5x by 2 minus cos of 7x by 2. So it is not cos of 7x the whole divided by 2, the angle is just divided by 2. And further I have minus root 2 minus 2 root 2 cos square x and plus root 2. So this minus root 2 and plus root 2 gets cancelled, right? Now let's try to simplify our denominator more, because we have already simplified our numerator, so we'll keep it as it is now. Limit x tends to pi by 2, 16 root 2 sin x cos square x. Denominator, if I try to solve this, I can write this entire expression as defactorization. Again, both of them are the same defactorization formulas. That is cos c minus cos d, that gives you 2 cos c, or basically not cos, it is sin. So it becomes 2 sin c plus d by 2 into, in this, if you remember, the d angle is greater, so it will always become sine of d minus c by 2. So even if you write sine of d minus c by 2, then it is positive. If you want to write it as sine of c minus d by 2, then you will have to take a negative sign here, right? So that is the idea. So if I use it here in this form, cos c minus cos d gives you 2 sine c plus d by 2. So x by 2 plus 3x by 2, that is 2x. 2x by 2, that is x. And further, if you see, it is sine of d minus c by 2. So sine of d minus c by 2, that is 3x by 2 minus x by 2. So d minus c is 2x by 2, that is x. And d minus c is x and by 2, so it becomes again sine of x by 2. Further, plus, again the same idea, cos of 5x by 2 minus cos of 7x by 2, I can again write it as 2 sine 5x by 2 plus 7x by 2, that makes it 12x by 2, that is 6x divided by 2, so it makes it 3x. And sine of d minus c by 2, so d minus c, if I do 7x by 2 minus 5x by 2 is 2x by 2, that is x, and it is x by 2 minus 2 root 2 square x. Right? Now let's understand how to solve this further. So let's see that on the next page. I have limit x tends to pi by 2. Numerator is still 16 root 2 sin x into cos square x. Denominator I have now. I can see 2 and sin x by 2 can come out common, right? So I can take it common again. So 2 sine of x by 2 common, and what remains in the denominator in the second bracket is sin x plus sin 3x. So I have sin x plus sin 3x, and it is minus 2 root 2 cos square x. So if I solve it further, limit x tends to pi by 2, numerator is still same. And here if you see, I get 2 sin x by 2. Sin c plus sin d, again a defactorization formula as we saw in the first thing. Sin c plus sin d, it was also same, sin x plus sin 3x. So I can just copy whatever the solution we get here. So we got here as 2 sin 2x into cos x, right? Because I have the same thing, sin x plus sin 3x here also. So it came out 2 sin 2x into cos x and minus 2 root 2. Now here if you see, the problem I'm having here is, if I substitute the limits as x as pi by 2, sin pi by 2 is always 1, so that's not an issue for me. But if you see, cos pi by 2 turns out 0 in both the cases, right? So that here also it is 0, here also it's 0, so it gives you an indeterminate form, that is 0 by 0. So in that case, if I want to solve this further, limit extends to pi by 2, numerator 16 root 2 sin x cos square x. And here if you see, I can also use 2 into 2, that is 4. Sin x by 2 is there. Sin 2x, I can still write it as using double angle 2 sin x cos x into 1 more cos x is present, minus 2 root 2 cos x. Now I can see, in the first part also I have cos square x, in the second part also I have cos square x. I can just take it out common. So if I take it out common, limit extends to pi by 2. I have 16 root 2 sin x cos square x upon cos square x comes out common. Then you have 4 sin x by 2. But 4, instead of 4, I can write it as 4 into 2, 8 directly. So 8 sin of x by 2 into sin x. 8 sin x by 2 into sin x minus 2 root 2, right? That's only left in the second part. Now, if I further solve this, I can directly cancel cos square x by 2. Now, putting the limit as x as pi by 2 does not affect or does not give an indeterminate form. So, you can directly substitute x as pi by 2 and get the answer for the question asked. So, now the value becomes limit. I won't write the limit because I am substituting it. I get numerator 16 root 2 sine of pi by 2, that is 1, so sine 90, that is 1, and 8. This becomes sine of pi by 2 divided by 2, so sine of pi by 4, that is sine 45, and sine 45 is 1 by 2 into sine pi by 2 again, that is 1 minus 2. You get 16 root. This, if you see, I can write it as 8 by root 2 minus 2. So if I want to solve this further, how can I do that? I can rationalize the denominator. So multiplying both sides by root 2, I get here the entire expression changing to 16 root 2 upon 8 root 2 by 2 minus 2. That cancels 4 root 2. So I get 16 root 2 upon 2 root 2. 2 root 2 gets cancelled. You get 16 by 2. And what is 16 by 2? That gives you answer as 8. So the answer for the question which is asked to us in the limit, that we needed to find the limit for where x is tending to pi by 2 with the numerator and denominator, that answer turns out to be in this case as 8. And if you see, the option that matches in this question is B. So B is the correct answer in this question. I hope you have understood how to solve this question, right? Because it involves a lot of formulas to be used from trigonometry, which you would have studied in compound angles as well, right? When we use double angles, also we had used factorization and defactorization formulas to simplify our entire fraction that was given to us. And that finally substituting x as pi by 2 gave the answer as 8, which is option B. Right? I'll meet you again tomorrow with the next question. Till then, you can subscribe to my videos. Also like and share these videos with your family and friends so that it also helps them in the of IIT JEE. Thank you.